Morning, y'all. We're going to look at 4.1, our measures of angles. So first off, there's two different ways to measure an angle. It's in degrees and radians. The measure of an angle in degrees is the measure of a central angle. So if we have our circle here and an angle like so, our central angle would be from the middle of the circle. Each degree is 1/360th of the circle. Okay. Radian, we use the arc length over here, S, compared to the radius, R. So we say that theta, our angle, is equal to S over R. So it's a ratio between S over R. When you have one radius equaling one radian, so if I have when S is equal to 1 and R is equal to 1, then theta is equal to 1, which is 1 radian. So in other words, 1 radian is equal to 1 radius. Okay, so that's what we use in our unit circle. Another way to figure out how big our radius is using this. We say S is equal to 2 pi times R, where 2 pi R is just when we're talking about radians, we're talking about arc length. So 2 pi R is just the circumference of a circle. So what we're going to say is the section of the circle, or S, is equal to 2 pi times our revolutions, how many times we revolve around the circle. Okay. And so some examples. Let's do a half revolution around a circle. So that would be like from our initial side. Remember, initial side is the side on the x-axis, and our terminal side is wherever we end up. So initial is where the arm stops, terminal. Okay. So in this case, a half revolution, half revolution. What is the arc length of that half revolution? We can use our formula. So the arc length S is equal to 2 pi times my half revolution. My 2's cancel, giving me pi. So the angle is equal to pi, or 180 degrees. All right, let's do a quarter revolution then. So S is equal to 2 pi. So for the whole circle, a quarter of the whole circle, basically, which is pi over 2. Lastly, so from here to here, a quarter of the circle, 90 degrees, that's an arc length of pi over 2. Let's do 1/6 of the circle. So 2 pi times 1/6 is equal to pi over 3. I'm going to get rid of some of this for you. Okay, so pi over 3 would be a sixth of the circle. So that's half, and then quarter, and I got to cut that into 6. Oh wait, just kidding. Okay, half, and then I got to cut the top into thirds. So from here to here, from my initial to my terminal side, that arc length is pi over 3. Okay, so S is equal to pi over 3. Okay, so some common radians. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. So a third of pi would be 60 degrees. Half of pi would be 90 degrees. Pi is 180 degrees, and 2 pi is equal to 360 degrees, or a full circumference. A reminder of what quadrants each one of the angles is in. So our initial side starts on the x-axis. Going positive, it opens up counterclockwise. So from 0 to 90 degrees, let's change those to radians. That would be 0 radians is less than theta, which is less than pi over 2. The second quadrant would be Pi over 2 is less than theta, which is less than pi. So this is 0, pi over 2, pi, 3 pi over 2. So pi is less than theta, is less than 3 pi over 2. And 3 pi over 2 is less than theta, which is less than 2 pi. And then it just keeps going around and around and around in a circle. We're going to sketch the angle in standard form. And then we're going to go ahead and find two coterminal angles, one positive and one negative. Do you remember what coterminal means? It means that it ends, the angle has the same initial and terminal sides, but a different angle measure. Not meaning radians or degrees, it means like adding 2 pi or subtracting 2 pi. So more rotations, more or less rotations. All right. Okay, so 11 pi over 6. What I do is I split up my circle into sixes. So I'm like 1, 2, 3, 4, 5, 6. So the bottom number tells me how many wedges to cut on the top. And then I go 5, 2, 3, 4, 5, 6. So 12 wedges total. I need to count 11 of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or I can think that this is really close to 12 pi over 6, which is 2 pi. And you're just subtracting out pi over 6. So we're just missing one wedge here, just that one wedge. So the angle here, theta is equal to 11 pi over 6. Okay, and from there, what I want to do is find two coterminal angles. So a positive coterminal angle, I'm going to take 11 pi over 6 and add 2 pi times n, where n is equals any integer. Okay, so basically n is any integer or revolutions, adding or subtracting revolutions. So I'm going to take 11 pi over 6 plus 2 pi times 1 for an added rotation. And I get 11 pi over 6 plus 12 pi over 6, which gives me 23 pi over 6. So if I add another 12 wedges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, sorry. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We end up in the same spot. Whoop-de-whoop. Okay, next. 11 pi over 6, so that's one answer. Plus 2 pi times negative 1 would be a backwards rotation. Gives me 11 pi over 6 minus 12 pi over 6, which is negative pi over 6. So if I start at my angle here, 11 pi over 6, and then I subtract 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you can see that we moved negative pi over 6. Okay, we're going to sketch in the next one is 7 pi over 3. So the bottom number tells me how many wedges to cut the top into. So I'm like 1, 2, 3, 4, 5, 6, because it's 2 pi around the circle, not 1 pi. Okay, now we're going to sketch in 7 pi over 3. So we count 1, 2, 3, 4, 5, 6, 7. So my terminal side would end up right here. Okay. And that goes around once and a little bit. That is 7 pi over 3 because it's more than 2 pi. And so it goes extra. So we're going to take 7 pi over 3 and we're going to add 2 pi n. Remember, that's any number of rotations. So I'm going to take 7 pi over 3 and I'm actually going to subtract 2 pi this time. So I get 7 pi over 3 minus 6 pi over 3, which gives me a positive pi over 3. So another angle that ends in the same place would be pi over 3. So just counting one wedge here. All right, we're going to take this pi over 3, 7 pi over 3 minus 2 pi, or plus 2 pi times negative 2 rotations now, would be 7 pi over 3 minus 4 pi, which is 7 pi over 3 minus 312 pi, which is, let me go a little bit more space, negative 5 pi over 3. So let's count. We have from the starting point, from the initial side, 1, 2, 3, 4, 5. So right here, again, but this time we're going backwards. You're all good. Yeah. Okay, so complementary angles, remember, add to 90, and supplementary angles add to 180. We're really used to doing these in degrees, but in radians, not so much. So complementary, we cannot write in highlighter. Let's try that again. Complementary angles would be 90 degrees minus the angle you have, which is theta. Okay, so in our case, we'd have 90 degrees minus 75 degrees, which gives us 15 degrees. If we look at that on, if our angle is 75 degrees, our complementary angle to make 90 would be 15 degrees. Okay, our supplementary angle would be 180 degrees minus theta, which is 180 degrees minus 75, which is 105 degrees. So if I draw that, 75 degrees plus 105 would give me my supplementary angle. Okay, pi over 6. So pi over 6 looks like a sixth of half of the circle. So to make a complementary angle, we got to add, how many sixths do we need to add to get to 90 degrees? We need to add complementary angle. The long way is to take your angle at 90 degrees minus pi over 6, and we're going to get pi over 3. So the short way is to just look at this and be like, oh, well, there's 2 edges missing. So that's 2 pi over 6, which is reduced to 3 pi over 3. Okay. For our supplementary angle, these are even easier. I'm going to look at pi over 6. I have 1/6 of the whole thing. So how many am I missing here? I'm missing 5 of the 6. The long way is to take pi over pi, which is 180, sorry, pi, and subtract your theta. So pi minus pi over 6 would give me 5 pi over 6. Okay. All right. We're going to convert degrees to radians and radians to degrees, and I gave you a little image over here. So if you have, so if you're in chem, then you're going to do a lot of unit conversion. This is the same, okay? So we're going to take negative 135 degrees, and we're going to convert to radians. So we have radians over, my parents just got here, you know, they're probably going to be loud. 1 pi over 180 degrees, and then you simplify. So 135 divided by 180 gives me negative 3 pi over 4. And that's your angle in radians. Lastly, we're going to take 7 pi over 3. We're going to multiply by what you have, what you want over what you have. I want degrees, so 180 degrees. What's equal to 180 degrees? Well, pi radians. Okay, so we're going to cancel our pi. 7 times 180 divided by 3 is 420 degrees. And we done. See you guys later.